Hello everyone and welcome to a continuation of the AP Computer Science videos on string methods. We're going to continue where we left off last time by talking about different methods that we can use. Last time we discussed the ability to use the constructor to make copies of strings. That was the first thing we did. We talked about the length method and our ability to count how many characters are in a string, whether there are 0 or more. We talked about the ability to compare two strings for equality. And we said that was the equals method, and it returns true or false, either they're the same or they're not, and it is case sensitive. And then we talked about the compare to method, which was very similar to the equals method, but gave us more information as a number. It would say, if they're equal, you get 0 as an answer. If the caller, the one calling the method, is smaller than, and this is in terms of lexicographical order, then we would get a negative value, and if it was larger or came later in our list of orderings, then it would be a positive number. We did several examples of that. So two more methods that we're going to talk about that are very powerful, and I'll mention one of them is probably the most useful that we will see, and it is used all the time. Gives us the ability to either look into a string to see what's there, to find things if they exist, so the ability to search into a string of characters, and the ability to cut up or take pieces of a string. And that's a pretty powerful thing. Before we do that, I want to mention something that I don't think that I mentioned in the other video, but it's important to recognize, is that strings are what we call immutable. To be immutable means to be unchanging. And so I'll say the reality is that when we have methods that seem to manipulate strings, they don't actually manipulate the string itself. They make a copy, and the copy has a changed value. We haven't seen any that have done it, but we're going to very soon see a method that theoretically looks like it changes the string, but doesn't actually do so. It makes a new copy with a different content, and then if we actually want to point our variable to look at the new content and erase the old one, then that can happen. But no string is ever actually changed by any method that we can use. It's not possible to do. You can assign a variable to look at a different string, but that's not changing the original. As opposed to, for example, an int variable. When you have an int variable and you say it equals a value, and then later on you say it equal to another value, you are literally changing the memory values, the memory locations stored content. With a string, we're not doing that. The string stays in the same memory location, and at best, we're finding some new RAM with the new string, and we're looking at that new RAM instead. And it gives us the illusion of values changing, but it's not really the case. And we'll see in a little bit what I mean by this. But we should just keep that in the back of our minds that strings don't actually change. They are immutable, and therefore when we look like we're reassigning a string, we're only pointing to somewhere new in RAM. We're not editing the original string. So I want to point that out. So let's go ahead and start with a new method. The method I'm going to talk about is index of. So index of method. And again, the index of method, notice it is camel case. And what the index of method does is returns the index of the first character in a matching search input. Which, oops, I should probably go over to another line. Oops. There we go, which is also a string. So what we're saying is, I have a string that calls the index of method. The input to index of is another string. And what we're going to do is we're going to say, can you find the position of this new string in the other one, in the caller? So we're like digging through it and say, did you find a match? So for example, we're going to look for particular words, and if we find them, then we will be able to match them. Now, when I use the word index, we should ask, what is an index? And typically an index in the regular world, it's usually a reference point or reference number that we use to order things, right? So index cards are a set of cards that we usually put in a particular order, and you can say go to card 7, and that's the card you're looking for, right? Or the index of a book has all the words or information in a book, and when you look through it, it tells you what page they're on, right? It's a mapping of content to position. And so the index in a string, the way it's going to work is that every single individual character in a string has an index value that is an integer number. And so, for example, if I wrote the string hello, And so I'm going to go like this. I'm going to say our string is hello. Then I'm going to say that if we had to write the indices, I'm going to put them on top. Then we would say H is index 0. E is index 1. And I'm going to put spaces between them so we can see this a little better. So H is index 1. H is index 0, E is index 1, L is index 2, and then the second L is index 3, and the last value is index 4. So what we'll have to say, we'll mention this. We'll say all strings, let's say all string characters have index value, and all strings begin index values at 0. The first one is always 0 no matter what. There's only going to be one string that has no indexed values, and that is the empty string. If you have no characters, there can be no indices. So this applies for strings that are 1 or more. If there's one character in your string, its index is 0. If there's 40, then you have the indices 0 to 39. And so if we want to generalize, then we can say a string of length n contains indices 0 to n minus 1, right? So and again, the example of a 40 character string, we're saying that the indices would be from 0 to 39. It's always off by 1. And this is an important idea to remember because it's going to apply to the next method, to this method, and many, many things we're going to be doing in the future. And it's one of the biggest errors that will happen to beginner programmers is forgetting that sometimes things are off by 1, particularly with the indices in strings. So we'll see it again pretty soon. And so let's go ahead and try this index of example. So I'm going to make a string called message, and it's going to be praise the sun. And now I might be curious and say, I want to look for the word sun in my string, and I want to know where it's positioned. So again, just to be clear, if we were to count indices, we would say the P is at 0, R is at 1, A is at 2, I is at 3, S is at 4, 5. The space is at 6. Spaces are characters, so that's at 6. T is at 7. H is at 8. E is at 9. Space is at 10. S is at 11. And so on. The idea is that every character, spaces, the only ones that might throw you off, and this is what I know can happen, is, for example, \n. That backslash is not part of the count. If I were to, and we can prove it. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and I'm going to say 16. I claim there are 16 characters. Let's see if the length method proves that correct, and then if we do our indices, we can see if that's really the case. So I'm going to go ahead and print out, and I'm not going to put it in a variable. I'm just going to print out directly because I'm allowed to do that. I'm going to say message.length, and I hope that I'm right in seeing the number 16. And there it is. It's not 17. The escape character, when it's doing its job, does not count as a character in a string. That is not the letter, that is not the characters slash and then n. It is \n, which is one character. And so that means that when we have an index, this last index, it does have an index, but it's not going to be index 15 and 16. It's going to be index 15 because it's one character. Right, 16 characters long. So the length is always one more than the last index. Or we could say the last index is always one less than the length of the string. Those are good things to keep in mind when we're dealing with strings. So let's go ahead and try this. Now that we have our message, I'm going to say found index. Where did we find our answer if we found one? And we're going to say message.index of, and I'm going to search for it. I'm going to put a literal. You can put any string you like. And if you put a string, then it's going to look for it, and it's going to return the index of the first character match. It has to match the entire search input. So if I look for the word capital sun, it has to find capital sun. But it's only going to return one number, where the S of the word sun began. So I'm going to say, can I find the word sun? And we should hopefully get a number that represents it. So here we go. We're going to say print out index found, and we'll do found So let's see what happens. If this is 15, it'll be 14, 13, 12, 11. I believe we should get the number 11. And there it is. Because the entire thing matched. Now let's go ahead and prove this and see if it doesn't work. Let's look for the word sunny, sunny with a Y. And let's see what happens. And this is going to bring us to another point. What happens if you don't find a match? What does index of return? It has to return an integer value because that's the rule. And so I don't know if I wrote it, but I should have done that. This says, oh, I said to return index, and I'm going to put as an int of the first character of the matching search input. If there is no match, so let's go ahead and write that. If there is no match found, the number -1 is returned. So I think that we're going to get -1 because even though the word sun does show up here, the full string sunny with a Y does not show up. So let's see. And there it is, -1. It says, look, I couldn't find it. Similarly, case sensitivity is a very big deal. So if I look for lowercase sun and I run it, I'm going to get -1. The capital sun and the lowercase sun do not match. A match is character for character match. So let's look at this. Let's say if I did capital SU, are we going to find a match? The answer is yes, because SU was easier to find than sun, and it's the exact same position. Now, let's try something like E. There are 2 E's in the string we're looking through. Message has 2 E's, the E in praise and the E in the. Which index are we going to find? Index of it's a good method, but it's very simple, and it returns the first match. So if there are multiple matches, you're out of luck. It's only going to return the first one. So if I run it, we should get 0, 1, 2, 3, 4, 5. And there it is, 5. So we find the index of the match, or we get -1 if we find no match. We can search for single characters or multiple characters. So if I want to look for like a word within a sentence, index of is a great choice. Because then I can say, oh, did I get -1 or did I get a value? Right? And so this is useful because we get 2 pieces of information. One is whether we found a match or not. That's one piece of useful information. And the second piece of information is if we found it, where did we find it? So that can be very powerful as well. And that number can be used in other methods, and we'll see in a little bit how we can take advantage of that. So index of is a great method. The last method that we're going to discuss that's on the AP exam. So far, all of these are on the AP exam. I'm going to mention 2 more quickly afterwards that are not, but they're very helpful and they can do interesting things for us. And there are several more that I have not discussed, and we can maybe glance at the Java API if we're interested, but they're not our focus here. They're not our focus here. So we're going to do the last method, and we're going to call this the substring method. I would say this is probably the most important method to understand. There are 2 versions of it. So substring, I'm going to put n so that there's 1 input, and we'll see how that is, right? Or actually, we're going to call it start. And so we're going to say substring start method. Substring returns a new string built from the characters starting at the specified index. So actually, I should maybe give this a better name. It's called start index. All the way to the end of the string. So this version, and so I'm going to go ahead and actually maybe put that here. I'll put this version 1. Version 1 takes in 1 input. It takes in a number that represents the index that we want to begin copying characters, and it generates a new string for us. So its output is a string, and that string is returned, and it contains all the characters from start index to the very end of the string. So let's try this. We have the string message, praise the sun, and so if I just want the, actually, to make this easier on myself so I don't torture myself, I'm going to get rid of the \n just because it's a little bit easier that way. If I want the word sun exclamation point, then what I would say is start at the index of the S and then go to the end. So here we go. I'm going to say string word is equal to And again, it's dot notation. The variable that we're referring to, this is the context. Whose characters are we looking at? Because there are many strings that we have in our program now, and they all have their own context. They all have their own set of characters. So we're dealing with message right now. Dot substring. We're going to give it the beginning index. And I'm going to say the beginning index I know is 11 for the S. So I'm going to say, you know what? Oops. Let's go from 11 to the end. And notice it returns a string. That's why I must put it in a string variable. Let's print out the word. So let's do system.out. Word equal to word. There it is. So we attach them, concatenate them. Let's run it. We should see sun exclamation point. And notice it does include the exclamation point because it goes to the very end. And now I'm going to go and put that \n in on purpose so we can see what the output looks like. And notice what happens is there's an extra blank space because that character is included. And it may seem odd, but a \n is a valid character and moves the cursor down. And then because we use println, it moved a second time, and that's why this green line ends up separate, and we end up with a blank line. And so if it's in the string, it counts. So this is a pretty big deal. Substring is a great tool for cutting up a string. But right now, the problem is basically I could get parts of the string, but it always goes to the end. What happens if I wanted the word the? But fortunately, if I knew the index of t, I wouldn't just get the word the. I would have to go from the to the end. So the sun. Okay, but if I want just the word the, I should be able to tell it where to start and where to end. And so this is where the second version of substring comes in. So let's go and put version 2. And so this substring takes a start index and an end index. But I'm going to point out something, and I'm going to write it. The end index is not included in the result that we generate. Right? I'm going to say it again in a moment, but this is important to say. So we're going to say the same thing. Returns a new string built from characters, from the characters. I realize I should put this here. From the characters starting at start index, and ending, but not including end index. And this is super important because this is always a sticky thing that catches new programmers, is that it's not inclusive of the last character. So we have to make sure our math is right when we do this so that we don't screw things up and we don't miss characters on accident or go too far. Okay, so let's try this. We're going to say word is equal to, and I want the word the. So if we look at our message, let's count our indices. 0 for P, 1 for R, 2 for A, 3 for I, 4 for S, 5 for E, 6 for space, 7 for T. So I want 7, 8, 9. But if I stop at 9, it's not going to include 9. It is not inclusive of the last index. So I'm not going to get the word the, I'm going to get the word th. So I should go up to 10. So 7 to 10 is going to be 3 characters, and the result will be the word the. So I'm going to say message.substring 7 to 10. And notice that it is 2 inputs. The inputs are comma separated. Just like the math.pow was the same way. We had a base and the power. Here we have the start and the end. And let's go ahead and print out our word. And let's see what happens. We should get the word the. And there it is. Now, a hint, a really quick way to know how big the string is going to be when you get it, is you do the subtraction. End minus beginning. 10 minus 7 is 3. That's why I know there are 3 characters. If I had made the mistake of saying, oh, index to index, if I had said 9 here, then I knew I would be wrong because 9 minus 7 is 2. I was only going to get 2 characters anyway. And then it's not inclusive of 9, so I'm not going to get the E itself, and I'm going to end up with TH. So it is important that we remember substring that takes 2 inputs is from start index to end index, not including the end index. I repeat myself because this is a very common mistake. Even the best programmers can make this mistake. It's one of those things that if you don't think about it, if you don't remember that detail, you will lose characters or miscount or cause problems, right? So there is our substring method. We'll continue some more, and I mentioned I'm going to do two more methods, and they're very easy to use. And so let's go ahead and do that. But they're not part of the AP exam. So this is where these are just kind of like extra ones. And there are a few others. If you look them up and you're interested in talking about them, you can just share that with me and we can discuss other methods. But this is the end of the important ones for the AP exam. So another thing we might want to do is capitalize all the letters in a string or make them all lowercase. So if I have a sentence like praise the sun, if I want to change this to be more bold, I'm going to make it all caps. And so I can say something like string caps is equal to, and again, still dot notation, so who am I capitalizing? The string message. And there's a method called toUpperCase. And toUpperCase is another method like length that has no input. I still need the parentheses, but I do not need to give it any input inside them because it doesn't need any extra data. It has access to the characters, and it knows how to capitalize characters, so all we're saying is, can you generate a new string? And so here's an example I mentioned of a method that might sound like it changes the string calling it. You might think, and I'll tell you why you might think it, because if I did this, oops, let me go to the end. I'm going to stop for a second. No error. Now, the IDE is definitely nice enough to warn me, but if I wasn't in an IDE and I didn't notice this yellow line, this looks like it makes a lot of sense. Hey, make the message uppercase. But because strings are immutable, message is never edited. This generates a new string with each character from message capitalized and added to the new string. And so if I were not to save this somewhere, message is still untouched. And that uppercase string is gone forever because I didn't put it anywhere. So either I print it or I put it in a variable like I was suggesting. So this is definitely a problem. So here's why we put it in here. And now I'm putting it in a new string, but if I wanted to truly, quote unquote, change message, I would reassign it. Did I change the string itself? No. I just made the variable point to somewhere else in memory. I made it look or map to a different position in RAM. And that's not the same thing as changing the content. And we'll talk more about that in more detail as we make our own classes, but it's a problem that we have to kind of always be aware of. So now we can go ahead and print this out, and let's go ahead and say print out caps. So we should see praise the sun in all caps. And there it is. Notice a character, of course, can't be capitalized. A symbol, it already is whatever it is. And so this only really affects characters. And similarly, there is a lowercase version. So we can say message.toLowerCase. And if I print this one and I run it, we should see the lowercase version. And so the P is back down, the S is down, and so on. So combining some of these methods would be very useful. Imagine if I wanted the word sun, if I wanted the word praise, but all capitals. Here's one way I could do it. String pcap, I'm going to call it pcap for praise capitalized, is equal to. I'm going to capitalize the message string. So message.toUpperCase. Then I'm going to say pcap. I'm going to erase what's in it, which is the full word, and I'm going to make it only the substring, the portion that I care about, which is the word praise. And so I'm going to say pcap.substring. And where do I want to start? We know that the P begins at index 0. So 0, 1, 2, 3, 4, 5, 6. Remember, I'm going to 6 because I am not inclusive of the 6. If you think about it, 6 minus 0 is 6. That's how many characters I want. 1, 2, 3, 4, 5, 6. There's the full word. If I went up to 5, the E, it would not include the E. So I'm going to say from 0, 6. But this is on the capitalized one. I'm reassigning. So this is just like math. When we saw our compound assignment operators, we said take those into variable, adjust it, and reassign it. We're basically doing that here, but through a method. And again, behind the scenes, internally, we're not changing pcap. We're pointing it to somewhere else, so a brand new string is generated. So this is kind of an expensive operation. Making new strings can be very intensive, but we're not worried about that for now. So let's go ahead and print out this final result. Pcap. And we see the word praise. So let me do it a different way. So I'm going to go ahead and make a note here. Generate the word praise. A second way. could have done this. I could have said string p only. I'm going to call it p only because it's only the word praise is equal to message dot substring 0 to 6, which takes the word praise, but as its original form, which is capital P, lowercase r, and so on. And then I could have said p only is equal to p only dot to uppercase. So get the word by itself, and then capitalize the word, and then remember that capitalized word. That's another way of doing it. So let me copy this. We should see the same thing twice, praise and praise. And there it is. And now I'll show you a third way, which is a crammed version, and this is a matter of comfort. Version 3, same thing, generate the word praise. And here we go. This one's going to be the one that I like, but you have to be comfortable with to do it. So I'm going to say string. I'm just going to PRS for praise is equal to message dot substring 0 to 6 dot to uppercase, not to lower, to uppercase. And so this may seem odd, but we have to recognize the way our order of operations works is we said function evaluation or method evaluation. So what happens is the dot notation says, get the substring of message. What does this return? This returns a string. Well, strings have methods. So this string, instead of temporarily putting it in a variable, I have direct access to it immediately, and therefore I can call the same methods on this one. And so to uppercase. And there it is. And then now I could just go ahead and print PRS, and then I should get praise a third time. And this whole idea of like chaining method calls, there is almost no limit to it. So imagine if I did this. I said substring 0 to 6, which gives me the word praise. Uppercase, capitalize it. And now I just want PR. So I could say so substring 0 to 2. That would be the P and the R. And then I could say lower dot to lowercase. And this is weird, but you can do it. The chaining of methods is quite possible as long as the data type of the previous call is a type that has methods. So this generates a string, which then can be converted and generated into a new string, which is converted into another string, a new string, which generates yet another string. And so at the end of this thing, I can call, if I print it, I should see just lowercase pr is what I believe. And there it is. Right? So I would say that chaining is a pretty reasonable thing to do, but you don't want to overdo it. This is a terrible... First of all, it doesn't make a lot of sense to uppercase something if you're going to lowercase it anyway. But generally speaking, you don't want to overdo it. So, but I do want to point out that it is convenient to do this. So I'm just going to go and leave this how it was. And so these are 3 ways of getting the same exact string. We're using these variables together to be comfortable. So I'm going to go ahead and stop the video here. And I'll see you in the next one.